Okay, so we are going to review graphing exponential functions. Let's start with the exponential function y equals 4 to the x. We are going to substitute in each one of these input values for x, and we're going to receive an answer for y. We can't use a calculator. So I'm going to start here with an easier one. When I do 4 to the second power, that means 4 times 4, which I know is 16. 4 to the first power is 4. Any number to the 0 power is 1. Now when you see 4 to the negative 1, it says 4 is not happy on top, so we put it on the bottom, and it has a reciprocal, so 1/4. 4 to the negative 2, again 4 is not happy where it is on top, it goes to the bottom, and now 4 squared is 16. When I compare these two, they should be reciprocals of one another. That's like flipping them. 4 over 1 becomes 1 over 4. 16 over 1 becomes 1 over 16. I'm now going to graph these. I understand some of these will be off the graph. So I go to 0, 1, 1, 4. So 2, 16 would be way up here. I'm just going to approximate. I go to negative 1 and 1/4 and negative 2 and 1/16. Now what I want you to recognize is that this will never cross over the x-axis unless we see a vertical shift. So when I go through and connect these dots, it looks like this. This is the exponential function y equals 4 to the x. No calculator can be used. This does not have an x-intercept. It never crosses the x-axis. So I'm not going to put 0 because that would mean the x-intercept is 0. I'm going to put none available, or write the word none. But don't put 0 because it kind of infers that the x-intercept is in fact 0. The y-intercept occurs at 0, 1. Now a lot of students forgot to fill this piece out. So I'm going to put down the basic information first, and then we'll fill it in. As we go to the left, what happens? As I go to the left and I look way over here, I can see it continues to get closer and closer to the x, closer and closer to the x-axis. So closer and closer to a y value of 0. As I go to the far right, it continues to go up without any limit. We're going to come back and do this next. But first, let's jump over here and let's look at this. I want you to write down y equals, and now we're going to add some transformations to the original exponential function y equals 4 to the x. So y equals 4 to the x, and now we're going to add some things to this. Let's go minus 3 plus 1. Notice the minus 3 is occurring in the exponent position, the plus 1 is in back. What does this tell us? It tells us we need to shift this entire graph, not 3 to the left. That's naturally what our brain says, but it's opposite of what you think, so it lies to us. We're going to go 3 to the right. So I'm going to go 3 to the right, and I'm going to make a dotted line. And then I'm going to go 1 up and make a dotted line. This is now my new origin. And when I graph this, I'm going to come directly back over here, because it's this function that's just been transformed. So I get to use this information. Well, how do I use this information? This is like the origin. So when I graph 0, 1, 0 is the x and 1 is the y. 0, 1 is just right here. 1, 4 says go over 1 and up 4. 2, 16 would be go over 2 and way up here at 16, right? So it's coming up like this. Negative 1 and 1/4, negative 1 and 1/4 would be negative 1 and 1/4, negative 2 and 1/16 would be negative 2 from here, negative 2 and 1/16. This is the transformation of this original graph. The last two things we're going to do here is number 2 and number 3 are going to be connected. So we want to take this original function, here's the original function, and algebraically we want to identify the inverse of it. Well, how do we find the inverse? We switch the x and y, and then we have to isolate the y. So if I want to solve for y, I need to somehow remove the 3. And we're going to use log. So I'm going to do log base 3 on both sides. The little base is the 3, and then I write everything down that was originally there. The log base 3 of 3 is eliminated, and I have y equals log base 3 of x. So down here, I want to illustrate this means this is the inverse of function y. This is the inverse log base, oh sorry, I meant to say a 4. I meant to say a 4. I have no idea why I changed it to a 3. No idea. Changing that to a 4 right now. My apologies. If you're watching this video, you're probably really confused. Where did the 3 come from? Rightfully so. So this is the inverse of this original function. These are inverses of one another. If they're inverses of one another, we can come back to the inputs and outputs and literally just switch them. So watch this. I'm going to make a little table of values. And what used to be the x is -1, or -2, -1, 0, 1, 2, that would normally be in the x's. If these are inverses, we switch it. So this is -2, -1, 0, 1, and 2, and 1/16, 1/4, 1, 4, and 16. Let's graph it. So from here, I'm going to go 1/16, so barely to the right of 0, and down 2. Then 1/4 and -1, 1, 0, 4, 1, and 16, 2. Now, when you graph this, just so you know, this never crosses the y-axis. Unless there's a transformation on the inverse, this never crosses the y-axis.